Today, we're going to be detectives. We're diving into a statistical mystery where all the clues seem to point to the same conclusion, but the reality couldn't be more different. We're about to see how numbers, even when they're identical, can tell a very misleading story. It's a puzzle that really changed the game for anyone who works with data.
Okay, so take a look at this. This is the evidence. We've got 4 different data sets, famously known as Anscombe's quartet. Now just look at their stats. The average of X, it's 9 for all of them. The correlation, 0.816 every single time. Even the linear regression line, that trend line, is exactly the same. On paper, these 4 data sets are statistical clones. They look totally identical.
And that brings us to the big question, right? If all the important summary numbers, the averages, the variances, all of it, are the same, then the datasets must be the same too. I mean, it just makes sense, doesn't it? Well, let's see if that's true.
To really get what's going on here, you have to think of it like a magic trick. And like any good trick, we're going to break it down and see how the illusion works.
So our first clue is something we all know, the mean, or the average. It's supposed to be that one number that gives you the typical value. You add them all up, divide by how many there are. It's super common, super useful, but it can also be a master of misdirection, hiding what's really happening with the data.
The mean tells us about the center, but that's only one part of the story. To really understand what we're looking at, we need another tool, one that doesn't measure the center, but measures the, let's say, consistency or the chaos around it.
And that tool is called the standard deviation. All this really measures is the spread. Are all the numbers huddled up tight around the average, or are they scattered all over the map? A small standard deviation? That means things are really consistent. A big one? Well, things are way more unpredictable.
Let me make this super simple. Imagine 2 pizza places. They both have ads that say 20-minute average delivery. The average is identical. So which one are you going to call when you're hungry? The answer is hidden in that standard deviation. So restaurant A has a standard deviation of just 5 minutes. That means they are rock-solid consistent. Your pizza's going to show up right around that 20-minute mark almost every time. But restaurant B? They've got a standard deviation of 10 minutes. That's a ton of variability. Your pizza might get there in 10 minutes flat, or it might take 30. Same average, but a completely different and way more frustrating experience.
So here's the key takeaway. The average might tell you where the center is, but the spread tells you how much that center actually matters. It's the hidden story that a single summary number just can't tell you. Okay, so we get it now. We know about the average, and we know about the spread. We have the tools to see past the illusion. So now it is time for the big reveal. Let's finally see what these 4 identical data sets really look like.
We are officially done looking at the summary stats. For the first time, we're going to look at the raw data, plotted out on a graph. You ready for this?
All right, here's data set number 1. And it looks pretty much exactly like you'd think. It's a nice, simple, upward trend. The points make a pretty clear line. The numbers told us a story, and the picture lines up. Nothing crazy here. But now, let's pull up the second data set. And whoa. Okay, that is not a straight line. Not even close. It's a perfect, beautiful curve. The numbers told us there was a strong linear relationship, but our eyes tell us that it's completely wrong. The calculation totally missed the real pattern.
Get ready for data set 3. This one is just wild. You've got an almost perfect straight line, except for one single data point, way up at the top. That one little outlier is single-handedly pulling the entire trend line off course, tricking the math into giving us those exact same summary stats.
And now for the grand finale, data set 4. This one is the ultimate trick. There is no relationship here. 0. It's just a bunch of points in a vertical line with one massive outlier way off to the side. That one point, all by itself, creates the entire illusion of a relationship. It fools the math completely.
So there you have it. 4 data sets with virtually identical numbers, and 4 completely, totally, dramatically different stories. The numbers didn't lie exactly, but they sure didn't tell the whole truth, did they? Which brings us to the big moral of this whole mystery. It's the fundamental lesson that this quartet of data was designed to teach every single one of us. You see, the guy who made these, Francis Anscombe, he created them back in 1973 for a very specific reason. He wanted to push back against this idea that calculations are pure and exact, while graphs are just sort of rough sketches. He proved so brilliantly that sometimes a graph is the only way to see the real truth that the numbers are hiding.
So what do you take away from all this? I think it boils down to a really simple mantra. First, look beyond just the average. Second, always remember that summary statistics can hide what's really going on. And the most important one, always visualize your data. A simple chart is one of the most powerful truth-telling tools you have.
And I'll leave you with this final thought to chew on. After seeing what we just saw, think about the numbers you see every day, in the news, at your job, and reports you read. Which of those numbers do you just trust, without ever asking to see the picture behind them?